1 minute left. Yeah. Can you hear me? Test, test. Okay, fine. Okay, so let's get started, or maybe wait 1 minute before, because other people are joining there. Yeah, let's take the chance to introduce myself already. So, I'm David. I'm working as a principal solutions engineer in Germany. So, please apologize if my English is not like the English of a native English speaker, but yeah, it will work. I'm pretty sure. So, first an introduction, or first the agenda. Yeah, we are talking a little bit about ways to query in Couchbase server, right? So the focus of this talk is actually on views, right? So indexing via views. As you have heard in other talks, actually we have multiple ways to index now, especially for Couchbase Server 4.0. And I just want to make clear that this talk today is more or less focusing on views and not on our global secondary indexes. Okay, so this is the reason why you can see this big 3.x there, right? just to, yeah. Okay, in the first step, let's talk a little bit about key value access and view access and stuff like that. Who of you already uses views in production? Okay, fine. So most of you know what it is, right? So anyway, if you used Vue in the past, you may have realized that they don't give you the same level of performance as our key value store, right? Given the fact that our key value store is very memory focused, which means that whenever you can, you should read data directly from the key value store, from memory directly, instead asking a view. It's indeed use case dependent, which means that sometimes it is just necessary that you use views in order to perform range queries, stuff like that. And for most of these cases, they're really good enough. But yeah, whenever possible, just use key value access, right? Because it has another level of performance, basically. Okay, so let's talk a little bit about how to query data in general from Couchbase, right? So who of you knows about data modeling basics and key patterns and stuff like that? Okay, so just a small introduction, right? So as you know, we are in the first step a key value store, and in the next step a document database, which means that you store in Couchbase documents as key value pairs, which means that one of the most efficient ways to query data from Couchbase is via key patterns, basically, right? So what you can do is you can define a key pattern like user : first name or dot last name or underline last name. And if you know that your key is exactly following this pattern, it is just possible for you to get your data back in one step by performing one get operation, right? You don't need to traverse an index in order to do that, right? Okay, and the next thing is, even if you have something like, I would like to, an example. Let's assume you have an application and you would like to log in by using the email address and the username, right? There would be two ways to find your user based on the email address. The first way would be that you just create an index on the email address attribute and then search for the user by performing a view query, right? Or later than a nickel query. The thing is that if you do this, you have to be aware that this is basically traversing a B+ index, right? A B+ tree index, which means that the complexity to find your user by this email address is higher than just doing a get, right? And there, this lookup or reference documents are coming, which means what you can do is you can easily create another document, right, which has the key pattern email : email address, which is referencing the original user document, and it's more efficient to just query this way. So what you do is you get in the first step this email reference document, and in the next step then the user document. This has a complexity of 2, given the fact that you designed it to be from memory, to get it from memory, whereby the operation to traverse this 3 index, which our views are, so b+3 index, has a higher complexity, usually something like log of, O of log of n, right? Okay. Another thing which is, you can easily mix it up with counter objects, or if you want to get multiple documents based on a key pattern, then one of the ways to do this, you could create counters, and then based on those counter values, generate you some keys, and based on those keys, perform a multi-get or something like that, right? So this is just an introduction how you can query data from Couchbase. And the first way, as mentioned here, is via key patterns by using it if it is possible, right? Reference objects, multi-gets by using counters. Okay, so let's actually jump to views. Okay, so a view or multiple views are living in one design document, right? And they are defined by using incremental MapReduce, which means that you define them by having a map function. And this map function is basically emitting you at the end a key, which is your secondary key on which you would like to search on, right? And a value. And given the fact that it's incremental, it's working a little bit like this. You're setting, replacing, adding, or deleting, so performing CRUD operations in your key value store. And as soon as you do this, it will be indexed and put into your index, which is behind this view, right, based on the map function. So every change will more or less be processed by the map function. It will be not immediately processed, so our indexing happens asynchronously by default, which means I will show the default configuration later. By default, it's something like every 5 seconds, double check if 5,000 operations were performed, and then if yes, do this, right? So, but you can enforce that it is happening at query time immediately. I will show this. But important here is map and reduce. Map in order to create your entries in your index or materialized view. We will see that it has a double role there. And reduce in order to perform aggregations, right? So you basically put some, based on the keys, some entries in your B tree, and you can have values as well, which brings us to this slide, right? So this slide shows you basically that a view has actually currently multiple roles. You can use it as a primary index. If you use it as a primary index, what you do is you just emit every ID which is fitting your condition. So for instance, if you maintain a type attribute, you could in your map function say something, if the type is person, right, then emit me only the ID of the document without any value. And what you get is basically you get a list of every person, right, of the key of every person. This is similar to primary index, right? Primary index for persons, right? So, and you can use it as a secondary index, which means in this case you still don't emit any value. You just use it in order to emit based on another key, right? By having an alternative access path, right? Which an index is basically, a secondary index is. And the last use case is to use it really like a materialized view, right? So like you may know from the relational world, something which is giving you an alternative view on your data. In this case, you're not just emitting a key into your index or your view. You're emitting, in this case, actually a key and a value, right? Okay. So on the storage level, it's not exactly looking like this, but on the storage level, you have your indexing on the key by using a B-tree structure, and in the nodes, you also store values. And the logically, it looks a little bit like this, or it looks exactly like this. So if you query it, what you get is a table which is ordered by key, indeed, because this B-tree index is defining a kind of order, right? All the elements those are on the right side are equal or bigger than or greater than, and all the others are lower than, which means that it's defining a kind of sort order based on this secondary key, which you emit to it, right? Okay, so if you query it, you can see this, because what you get is you get rows back, right? And those rows have exactly 3 values. Each row has 3 values. One is the original ID of the document, which was processed by the map function. The other one is the key on which you emitted in your emit finally. And the third one is the value which you emitted, right? So let's give you some examples. Can you see this even there? Far away? Fine. Okay, so the primary index example is something like this, right? So you're using in our MapReduce, or you're using this map function, and the map function is basically just emitting the ID of every document which is processed. Yeah, so as soon as the document changes, as mentioned before, it is processed. The secondary index is looking like this. So you're checking if the name attribute is there. And if it is there, you're emitting into your view just the name attribute and no value, right? Because you have the reference back to the document anyway, as mentioned here, right? And yeah, the view is more or less looking like this, which means you're getting the document as the input of your map, and based on an attribute, you check if it is there. And if it is there, you emit it as the key. In this case, we are even performing a transformation from this flat key to a compound key. And as well, you're extracting some data or transforming some data from the document which is currently processed by emitting a value into your view, right? So those are the basically 3 roles. Those could be covered by using views, right? So, okay. For those of you those did not yet see our UI regarding this, it's looking like the UI here. So basically, if you log in, you have this Views tab, and there you can select your bucket, and then you have an example document. You can randomly get another one if it is interesting for you, and then you can write a view function here. Yeah, and we have a kind of built-in staging, which means that a view is in the first step as part of design document just created as a development view. And as soon as you tested something with it out, you can promote it to be a productive view, right? The reason is just that you would like to avoid to index everything just during the creation of this view. You just want to index a subset of the data for testing purposes, right? Before you promote this view to a production one. Okay, this diagram here, I hope really that you can see it. This diagram here is showing you that the advantage of MapReduce is not just that we allow to use JavaScript in order to define it. The advantage is actually that it's possible to index your data in parallel, right? So each node is indexing the data which is located on it, right? So what happens is if you change something, it changed on a specific node, yeah, based on the distribution, the sharding of the data, and as soon as it changed there, the map function is executed on this node for this data item, but on another node, another data item is processed in parallel, and so on, right? So if you query all this, it is a little bit similar, right? As soon as you perform a view query, you perform it against the REST interface of a specific node. This node will ask all the other nodes, hey, please give me your results, will merge you the results, and will provide them back to you, right? So this point actually needs to be moved a little bit down here, but our client libraries are taking care that not every time the same node is returning you the results. So if you use our client libraries for querying views, they will round robin across the nodes in order to make sure that not every time the same node is responsible to return you the view results. But if you would perform a REST query directly against one of the nodes, right, then basically it would work like this. Okay. It's actually quite hard to see this, right? Yeah, okay. I will anyway explain it. So you can use our view interface, our REST interface directly if you want. And this is just some examples how to do this, right? So you can have a simple view access. So just get every data which is in this view, which is in your index behind the scenes. You can perform an exact match query, something like, okay, where my email address is exactly this value, whereby we already learned that the email address is a little bit, maybe not the best example, right? Because in this case, you may decide to have this lookup document instead, which needs to be maintained by your application, by the way. You can perform range queries, right? So you can, and this is the real strength of such a B-tree index, right? The B-tree index just allows you to query for range because the range is basically a subtree, right? So, okay, and with reduction, with grouping, all this stuff. Let's jump to the best practices, right? Best practices are, because views can be heavy weighted, you should think about how to use them, right? And the reason why you are here is to learn how to use them the right way. So you should not compute too many things in a view. So if your view function, so your map function, has 500 lines of code, you're most probably doing something wrong, right? So keep it simple. Don't write too complex view functions, if it is possible. The same for emitting too many values. I mean, you can emit multiple values in one map function, right? And this is maybe necessary, but if it is really, really a high number of values, 1,000 values or something like that, then you should think about if your data model is maybe not correct or not the best fit for this use case. Check for attribute existence, right? So try to index only on attributes those are really there. So if this attribute is existent, then index based on this attribute, right? Pre-filter data, because one cool thing about views is, I mean, you can easily create an index in every database system. So you can create it in relational database systems just by saying create secondary index on. And what basically happens is that you index on the whole column for every value. This is different with views. In views, you can pre-filter what you index. So even if you have a lot of documents, a good example would be the type, and you would like to only index on persons, then you just double check on the type attribute which you have to maintain by your application or via your application if it is a person. And only if it is a person, you put this person into the index, right? So you can pre-filter up front, which helps you to get a better selectivity at the end. Yeah, and also best practices only to project the necessary values. Please don't emit the whole document, right? I mean, sometimes you see this. Sometimes somebody is starting to work with views and he thinks, okay, the only way how to get my value then based on this index is to emit the whole document. So you see something like, okay, this is my secondary key, I emit this as the key, and then the document itself. This is not best practice. If you want to have a lot of information from your document, you can just use the ID attribute, which is anyway part of your result set. So the original ID of your document which was processed in order to get back all the values you need, right? So really, really use it just, or if you use it as a materialized view thing, or by emitting only necessary values, not everything, right? And if possible, use the built-in reduce function. I mean, you can easily create your own reduce functions, but if it is possible and sufficient, don't write your own count function, because there is already a built-in count function, there is already a built-in sum function, and they are in a way already pre-compiled there, which means that it's more efficient to use them instead your own implementation of it, right? Okay, yeah, hard to see here, but in this case, we are only index on the first name if the first name is really there. In this case, we are only emitting if the person, if the type is a person, yeah, yeah, in this case as well. Yeah, and this is a good example for only emitting relevant data as the value, right? In this case, we are just interested in the first name and last name, whereby your person may have a ton of other attributes, basically, right? Okay, and the last way, not the last way, actually there will be another session about Elasticsearch today, which explains you that it's even possible to query via Elasticsearch, but built in the last way to query data out of Couchbase is to use Nickel, right? And I think there are a lot of sessions regarding 4.0 and Nickel, so if you want to have further details about this, just visit those sessions, or maybe you have already. But for those of you those did not yet see Nickel, which I don't think, Nickel is our SQL-like query language. It extends in a way SQL, right? And Nickel itself can use several JSON store implementation behind the scenes. So one of the implementations is our new global secondary indexes, so ForestDB, and it can also use views. So if you don't use the with GSI option and you use the developer preview of Nickel, it will basically create your view, right? And you can then query those views, indeed, directly via Nickel. You can't query every view via Nickel, only those were created via the create index statement. Yeah. Okay. So let's talk a little bit how indexing works. How many of you are using Couchbase 2.x? Most of you. And who is using 3.x? Yeah, it's maybe the same amount of people, let's say. So let's explain you a little bit. How many of you that were a little bit confused regarding the stale equals false behavior? I was, actually. When I used it the first time, I was. Yeah, so, okay. The 2.x architecture is actually looking like this. We have our managed cache. It's not the complete architecture, it's just to explain it a little bit. We have the managed cache here, and as you know from the managed cache, we are replicating over by using a replication queue over to other nodes. We write per default asynchronously to disk by using this disk write queue, and in 2.x, the view engine is picking up the changes from disk. Right? So as soon as something hits the disk, it can be indexed, right? Not before. This changed in version 3.x. In 3.x, the view engine is basically picking up the changes from the cache enabled by our database change protocol, which was also DCP, which was introduced in 3.x. Okay. Let's talk a little bit about the semantics of stale equals false, because this semantics of stale equals false is different between 2.x and 3.x, given the fact that 2.x did index the data from disk, whereby 3.x is indexing the data directly from memory, right? Which means if your data is not yet on disk, but in the key value memory, right, in the memory area which was showed there, then what you basically have is that even if you perform a stale equals false query, you will not get exactly what you have in your key value store. Let's explain the stale equals false. Stale equals false is a parameter which ensures that as soon as you perform a view query, you can say, I want to have my data non-stale. So please index my data, update my view before you give me the result back. Yeah. In 2.x, if the data was not yet on disk, you didn't see the data so far, right? In 3.x, it changed. Because in 3.x, indexing happens directly from memory. It's now, let's say, semantically correct. Yeah. The default value by is by the way, x stale update after, which means you perform a query, you get a result which is a little bit outdated maybe, and after you issue the query, the index will be updated for you, right? So the next one is more up to date and so on. And another option would be stale equals OK. Stale equals OK means you don't care about it, right? You only update the index quite frequently based on the configuration. So every 5 seconds, it's checked if 5,000 changes in the key value store happened, and if so, it will update the index, right? Okay. So database design considerations. Yeah, as you may know, views are living within design documents, right? And such a design document is not just a logical container, right? So if you use it the first time, you maybe think, yeah, okay, it's a logical container. I create my design documents by scope of my application. It doesn't matter how many design documents I have. I have one design document. The document, it means locations, and another one, it means users. And all my user-relevant views are sitting under users. All my location-relevant views are sitting under locations, for instance. Yeah, this would be something which what you do usually, right? But it's important to know that such a design document is not just a logical container; it's also a physical container, right? So, which means that a design document is more or less all the views within one design document are more or less indexed the same time, because a design document is on disk reflected as one file. And because a file is an exclusive resource or has exclusive resource access, let's say it this way, the indexers, yeah, those can work on one design document at the same time, are exactly one indexer, right? So it's important to understand that if you want to improve view performance, it may make sense to have multiple design documents. On the other hand side, you should actually not do exactly the opposite. So don't create one design document per view. Yeah, find something which is usable in the middle, right? And it basically depends on your use case and your performance requirements, what is the right way here. Yeah. Another thing is, it may happen that only a low percentage of your data needs to be indexed, whereby all the other data is just accessed via key accesses, right? Via key pattern accesses, for instance. In this case, it may be an overhead for you to execute the map function for every document change, even if those documents are not relevant for indexing purposes. In this case, it may be okay, or it is actually best practice to create another bucket and move the data which should be indexed in this bucket, and the data which should not be processed by any indexing in another bucket. Yeah. So if you have 90% of your data only for key value access and 10% of your data just for indexing or view access, then move this 10% out, right, to another bucket. Okay, and last but not least, you could even separate the indexing workload from the operational key value workload, right? Which means what you can do is you can create another cluster, and this other cluster is then only for indexing purposes, right? So you can connect this cluster, which is your operational one, hundreds of thousands of operations per second, has its operational workload, and the workload of indexing and querying is completely isolated by just having an XDCR link, cross data center replication link between your operational cluster and your indexing querying cluster. If you think about it, in 4.0, we are going into this direction by now having the possibility to assign an index role or a data node role or a query node role, right? This is something similar, but already with 3.x. So it's easy to see that you have then your reporting cluster there and your operational cluster there. So it's just about workload separation. Yeah. And not just about workload separation, even about configuration, because our views are benefiting quite from fast disks, right? Which means you would like to have SSDs maybe in your indexing cluster, whereby your operational one has another kind of storage, right? Then you could even separate this configuration, and you can configure on the indexing cluster another file system cache size and stuff like that, right? Can we move the questions? Yeah, because we have a quite tight time schedule. Okay. Okay, let's talk a little bit about configuration settings. I apologize that it's actually a little bit hard to read this. This is usually not the case, so has to be related to this projector. But the first setting we are covering is the index path, right? So which means it indeed makes sense to have another location for your indexes than for your data. So your indexes are, if your cluster is using spinning disks for any reason, right? Or let's say it's using spinning disks, then it's anyway recommended to use SSDs for the index, right? And in this case, you can just point to another mount point where your SSDs are mounted in order to have fast access to the indexes, right? Our indexing interval, this is something which I already mentioned, right? So by default, it's 5,000 changes and 5 seconds, right? Whereby it is the case that every 5 seconds there is a check if already 5,000 changes were performed. You can override this setting if you want, right? And you can indeed enforce that your index is updated before this condition is met by using the stale parameter, right? Per default, it's stale update after, which means that this setting is per default actually not every time applied, because you're anyway during querying and enforcing that indexing happens, right? The maximum number of in parallel working indexers is one setting, which means you can configure multiple indexers. So as we learned, each design document is one exclusively used resource. If you have 10 design documents, then you can process them in parallel. And even if you have 3 of them, right? But if you have multiple of them, you can process them in parallel. And how many you process in parallel at the same time is configured by using this configuration setting. Index where rebalance is quite interesting. It happens, per default, it's happening, right? So, which means if you rebalance, then and you perform a query against a view, you're not seeing that there is a rebalancing happening in the background, right? Because it's enabled usually, right? But you can disable it in order to speed up rebalance if this is a requirement. Okay. Our other settings are rebalance before compaction. It's less related to indexing, or it's more related to the disk load, which is there usually. But you can specify how many buckets are moved as part of the rebalance before it's paused in order to have some cycles for compaction. So you can play a little bit with the priority between rebalance and compaction at this point. Another one is rebalance moves per node, right? So you can decide how many rebuckets are moved in one step in order to control a little bit how fast the rebalancing is happening, and also how many load the rebalancing is causing. And this may be interesting for you regarding the disk load, right, which is happening, and indeed the network load. And disk load is on the other side, again, interesting for indexing performance. Yeah. Another thing is, I think all of you know what AutoCompaction is. Who knows what AutoCompaction is? Okay, not everybody? Okay, fine. So we have an append-only structure as a storage structure or storage engine, which means that we are appending data at the end all the time. We are not performing in-place updates because they are expensive. But the downside of it is that there is some fragmentation, and you have to remove this fragmentation from time to time. And for this purpose, we are using compaction. And you can configure compaction to happen in parallel with your views if you want, right? Okay, my last slide is more or less about resource requirements. If you use views, then you should have more CPUs, right? As explained before, there's a number of indexer threads, those are working in parallel and stuff like that. So usually we recommend a minimum of 4 CPU cores. And if you use views, then we would say 8 cores are okay, right? Because there is more happening, so it's not just disk I/O, it's also CPU load, which may be relevant here. Yeah. So more CPU load. So you should configure your operating system file system buffer, right? So, which means actually, if you access views, then we are making use of the file system buffer, right? So if your file system buffer is bigger, then you're getting the results faster. Yeah. So it's not every time possible to do this, right? So this is clear. This would be a use case where you use an extra cluster, which is then configured specifically for view access. And if possible, use really fast disks for use. Okay, any questions? Yes?
So my question was about the suggestion that we use another cluster with XDCR for querying.
Yeah.
Now, let's take an example. If we have a read-write cluster, only one cluster, 20% write load and 80% read load.
Yeah.
Okay. Now, unless you have multiple XDCR clusters for your read-only load, and we just have 1:1, and this is supposed to replace the original RW cluster, then the 20% write load is anyway transferred by the replication mechanism onto the new cluster.
Yeah, sure.
If you're going to have all the 80% RO load onto the new cluster, it's
Yeah.
just same
Yeah.
amount of I/O happening on.
No, yeah, it's the same. It's the same throughput you're expecting, or it's the same load, actually. But you can define your indexing cluster in another way than your operational one, right? So you can decide if your operational one has a higher amount of nodes, your indexing one can have a lower number of nodes, but maybe a higher disk class and a better configured file system buffer, right? So the idea is to not just separate the load. The idea is also to specifically configure it for your purpose, right?
You mentioned about the state of what is actually the data from you.
This.
What is the default value for
The default is update after, which means if you issue a view query, it will trigger an update of your index, right? So if you query the next time, your index is more up to date than before, but not up to date to the state you're queried, right? If you want to have it exactly up to date to this point of time, you have to need stale equals false. Instead, stale equals update after. No, in 3.x actually, you don't have to wait until the data is written to disk because in 3.x the index engine is picking up the data directly from memory, right? So you can control this then via the stale parameter. Nickel in 4.0 is more or less using the global secondary indexes, but can be used anyway with views, right? Yeah. Yeah, the sort order is actually based on the secondary key already given, right? Because it's a B tree, and this B tree is defining a sort order, right?
What happens is when I retrieve my document IDs, I'm forced to do multi-get, and I lose my sorting.
Yeah, it depends on which IDs are in your multi-get array. If you make a multi-get, you give it a list of keys, right? And sure, the multi-get is actually happening asynchronously in the background. So how it works is actually that even if you perform a synchronous multi-get via most of our APIs, Java for instance, then it's performing an asynchronous operation in the background, which means that it's sending all the get requests in parallel to the server, and because it's asynchronously happening, there is no guarantee regarding the sort order of the result, right?
So I am forced to sort it twice. Sort one.
Yeah, I guess you mean the multi-get based on the key set, but in this case you're not accessing views. In this case you're accessing the key value store, right? So this is less related to views. This would be even the case if you would create your key array up front. However you do it, right? Yeah. Yeah. Yeah, the worker threads. Good question. Let's go back. We can see this here. It's actually a global setting in this case, but I'm pretty sure you can override it per bucket as well. So there's a global setting, and this setting is the default, which is used for every bucket then, but you can also override it per bucket. Yeah, it's in Couchbase 3.0, but as you can, yeah, it's in 3.0 and it's available via the settings REST service. Yeah, it depends on the specific use case, but usually if you really want to have it in a consistent, right, so that the view state is exactly the state of your key value store, then you have to use state equals false, right? And the state, yeah, at the query time. But yeah, the good thing is that you can decide if your query should enforce an update of the view or not, right? So some of your queries may not care about the consistency, others may. So you can actually decide which queries should enforce an update of the view. And if you query more often, yeah, then you have less to index within this time frame, right? Usually this is the case, right? Yeah.
How can you monitor how much memory the indexer uses?
How much what?
Memory you're using. You're saying you're using
Yeah, the memory which it is using is actually quite easy to monitor because there is on disk there is a directory which is your indexes directory, and every design document has their file, and you can just double check the size of this file if you want to do this. In RAM, yeah, in RAM, this as mentioned before, we are using the file system buffer. So it's a maximum the size of the file system buffer configuration. So views are not served from our key value store RAM, right? So if you have a bucket RAM quota, then this bucket RAM quota is not including any memory allocation for views. Views are served from the file system buffer. Yeah, so it's something which is living a little bit beside it. It changes with 4.0, where our global secondary indexes have a managed cache on top of it. Yeah?
So can you force the index to be rebuilt, like put the data into
You can enforce it at query time. So you can, no, when you write, it's asynchronously written, right? But you can, at query time, enforce that there is an update, right? So you can just say, okay, my query with the parameter state equals false makes sure that the result is exactly the one at this point of time when I queried. Okay, any more questions? No? Fine, so thank you.
So how do I know